Hello. This is video number 67, and we're still taking a look at merge sort's worst case, even though I said we're done with it. We are. We already have the order of magnitude. The order of magnitude is order n times the number of times n can be split in half. Yeah, but we don't want to have to say that every time we're talking about merge sort, the worst case or the average case or any other case. So let's go off on a little bit of a tangent, shall we? Here's an observation. Actually, a collection of observations. Suppose list size n, capital N, is equal. Look at me using double equals. I don't want to assign it. I'm going to say it's already equal to 1. If list is size 1, we can't split it at all. Split 0 times. How is that for an observation? If you've got a list of size 1, if you called merge sort so many times, no. If merge sort has called itself so many times, it's split, till there's only one element left, then we can't split that any further. So when we get down to that bottom right before the dotted line, list size 1 can't split no more. What about n double equal to 2? Well, then let's see. Here's our list. You know what? These will be figs over here. That's not much of a fig, is it? Here's the fig. Here's my list of size 2 in this little tray or whatever. I can split that into 2 lists of size 1. How many times did I split that? Let me count. 1. Split 1 time. So much fun. Let's bump up to the next size list we might see in part of merge sort. What if n is equal to 4? A list of size 4. So here's my list of size 4. I can split that into 2 lists of size 2. I can still split further. I split until I can split no more. How many times did I split? If n is equal to 4, I can split it once, twice. Split 2 times. You know what? That is just so much fun. I'm going to do that again. What if n equals 8? Well, here's my 8. Can split that in 2 lists of size 4. Each of those gets split. 2, 2, 2, 2. And split again. 1's all over the place. 1, 1, 1, 1, 1, 1, 1, 1. How many times did I split the 8 into smaller lists? That's a 4, not a T. Once, twice, thrice. So how about split 3 times? Now I could do, allocate some space here. I could do n equals 16. Actually, it's going to make a pretty little Christmas tree, isn't it? But I'm going to predict anyway. Let's see if we can generalize and find a pattern here. 1, split 0 times. 2, split 1 time. 4, split twice. 8, split 3 times. 16, you know what? We're going to be able to split that 4 times. 32, we're going to be able to split that 5 times. Yada, 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 dot, dot, dot. What's the pattern? Let me change colors again to make the pattern stand out from all these pictures and examples. Red, that should get our attention. Pattern. What's the relationship between the length of the list and the number of times I can split it? How about this? Capital N is equal to, and this is an equation. I should put double equals, but that's just a little too cute, isn't it? N is equal to, let me suggest 2 to the t, lowercase t, where t is the number of times we can split n. Or n can be split. It's not necessarily us splitting it. It could be merge sort itself splitting it. N can be split in 2. Let me read that back. The pattern, or so I suggest, and we'll see if I can back it up over here with these examples. The pattern is that capital N, the size of the list we're going to try to sort with merge sort, is equal to 2 raised to the lowercase t power, 2 to the t, where that lowercase t is the number of times n can be split in 2. Let's start on the right-hand side of these pictures. 2 to the t. When t is 0, 2 to the 0, anything to the 0 power is 1. List size 1. T, the number of times I can split it. I can split it one time. 2 to the 1th, 2 to the 1st is 2. List size 2. So far, so good. I can split this list 2 times before I get down to single elements. If I can split it 2 times, then that's the value of t. 2 to the t, 2 to the 2 is 4. 2 squared is 4. I can split the list of length 8 3 times. It seems like it's holding water over here. I can split this 3 times. 2 to the 3rd. 2 times 2 is 4 times 2 is 8. List size 8. 2 times itself, 4 times is 16. And ladies and gentlemen, I think our pattern holds water. It deserves a circle. There. N equals 2 to the t, where t is the number of times n can be split in 2. Now that rings familiar, does it not? Look at this. The number of times n can be split in half, except t is that value. So we could say this is order capital N times lowercase t. Oh, no, we can't do that either. We can only have our parameterization, or the order of magnitude, based on the size of the list. Good grief, what was that? That was me without the energy to break things down and make them simpler, I guess. Whatever we put in parentheses has to be about capital N. You can't sprinkle in some X's and T's and all that stuff. That's not fair. So somehow or another, we got to finagle this around so that it's in terms of capital N. And that looks like it's an upside down, backwards, impossible task. But I'm going to clear some board space and take a shot at it. With your able assistance, of course. Is it getting dark, or is it just me? I'm getting dark. Where were we? Well, here's a recursive aside. This is an aside within an aside. Aside in green. I'm just going to pull this out of nowhere, if you will allow it. Or maybe I'm not going to wait for your allowance. I'm just going to do it anyway. Log, log. Yes, log. Log with a little 2 down here and an a here. We would read that log 2 of a, or log base 2 of a. Logarithms. You might have heard about those in math class. What does that mean? Well, if that is equal to r, if log sub 2 of a, log 2a equals r, that means the stuff in this other box. 2 to the r equals a. Those two statements are equivalent. Let me see if I can twist this back around into anything that makes any shred of sense whatsoever. That looks not too bad. That doesn't even have log in it. But this statement is actually equivalent to this. This one is saying log base 2 of a equals r. It means something. It's trying to tell us something about r. Look, forget about that. It's telling us that r, listen to this carefully, r is the exponent we got to stick on to get a. That's the definition of the logarithm. R is the number we've got to put as the exponent on 2 to get a. We can't use e here because e means something else in math. Sorry about that. So 2 to the r equals a. That's what this is telling us. Look at that. I just now said that. 2 to the r equals a. These two boxes have equivalent information, and I'm going to close off that aside before we get into any more trouble with it. What does that have to do with us? Well, it means it's time for a color switch yet again. Let's get back to where we were before all these asides. Back to trying to deal with this. N equals 2 to the lowercase t, where t was the number of times that we could split it in half. I'm going to write that down here because I'm going to do a little whiz-bang math on it, or I hope I am. Capital N equals 2 to the t. That was from the previous board full in the same video. Watch this trick. Since that's a mathematical equation, I can do the same thing to both sides at the same time if I want to. And I do. I want to find the log 2 of both sides. Log 2 of n equals log 2 of this thing, 2 to the t. Why do I want to do that? Well, who knows? It's late in the module. Maybe I'm losing my ever-loving mind. Maybe that's why I want to do that. Here was the original equation. Here's n. Here's 2 to the t. I just took log 2 and put that in front of both of them. Log 2 of n, what does that simplify? You can't simplify that. I don't know what log 2 of n is. That's hopeless. You're hopeless. I'll just copy you down. Log base 2 of n equals this one. I don't know. Let me see if I can fit these two things together. How did I describe this? I said log base 2 of a equals r means that r is the exponent I got to put on 2 to get a. Okay? How does that help me? What exponent, I wonder, what would be r? What exponent do I have to put on 2 to get 2 to the t? What exponent has to go on 2 to get 2 to the t? It's almost like asking, who was that buried in Grant's tomb? The exponent you put on 2 to get 2 to the t is t. It all disappears except for a little bitty t down here. You can think of that as an alternative definition for our own devious purposes here. Log base 2 of n is the number of times you can split n in half. That's exactly what it is. Log base 2 of n equals the number of times that n can be split in half. Now I've just got a little, like a miniature formula for it. I don't have to say it's ordered n times t. I can now, drum roll, say that in the worst case, merge sort is order capital N times log base 2 of n. We already had the capital N. We've been hauling that around for a while. Here's the mess that we just finessed away. The number of times n can be split in half. The number of times n can be split in half is log base 2 of n. That's the mathematical definition of it. There. That is a big important box. N log base 2 of n. So important. I'll put watch this, a double. Is this the first emergence of a double red box? This term. That's the order of magnitude of merge sort in the worst case, as if anybody really cares. We care. We care. We care so muchly. I'll show you how much we care in the very next video. That'll be it for this one. I'll see you online.